Ensuring personal safety is an important part of any overhead line work. A lineman must be prepared for the expected and the unexpected. Typical safety precautions include using rubber gloves and sleeves, using hot sticks, and grounding. In this program, we'll look at the part grounding plays in your protection when you're working on overhead lines. One of the purposes of grounding an overhead line during maintenance work is to protect workers if the line should become energized. In this program, we'll take a look at ways in which an isolated overhead line can become energized. We'll also use Ohm's law to demonstrate current flow in a grounded overhead line when it is energized. Finally, we'll look at a method of grounding called equipotential grounding. Now, before we get started, let's look at the definitions of some of the terms we'll be using in this program. Three of the terms we'll be using are energized, isolated, and de-energized. When we use the word energized, we mean that a line has a potential that is different from that of Earth, which is considered to be zero. When we say a line is isolated, we mean the line is separated electrically and mechanically from all sources of electrical potential. By the term de-energized, we mean that the line is dead. In other words, the line is isolated and grounded so that it has the same potential as Earth. For example, this line is energized at 7.62 kV. Opening these cutouts electrically and mechanically isolates this line from the source voltage. After the line is isolated, it is tested for potential. In this case, there is no potential indication, so the line can be grounded. When the grounds are installed, the line is de-energized or dead. Once the line is de-energized, it is considered to be safe to work on. So there are basically three states in which you'll find a line: energized, isolated, or de-energized, which is to say grounded. Now, there are several ways in which an isolated or de-energized overhead line can become energized. One way an overhead line can become energized is by closing a breaker or switch that feeds the line. Whether this happens accidentally or on purpose, the line will become energized. Another way is for the line to be energized from a foreign or unintentional voltage source. For example, a car hitting a pole can cause an energized line to come in contact with an isolated or de-energized line. Energized lines could also make contact with an isolated or de-energized line due to tree limbs falling into the lines during tree trimming work, other line maintenance work, stringing operations, or storms. Lightning is a concern as well. When electrical storms are in the general vicinity, work on overhead lines may be suspended. Although the immediate work area may be free of electrical storms, lightning strikes on other parts of the system could result in transient voltages that may make the work area unsafe. Another way an isolated line can become energized is due to mutual induction from nearby energized lines. This can occur when normal load currents in an energized line induce voltage and currents in an adjacent line. The level of voltage and current induced depends on the strength and size of the electromagnetic field of the nearby energized line and how close it is to the isolated line. In addition, dust particles suspended in the air in conditions of high humidity, such as fog, can become a conducting medium. Also, air passing over long stretches of isolated line can cause a static electricity charge to build up in an isolated line. One way to protect yourself in the event that the line you're working on becomes energized is to set up a work area that will eliminate or limit any current flow in your body. We'll take a look at how that works a little later in the program. But for now, let's look at a typical grounding procedure you may already be familiar with. In this procedure, grounds are applied to the isolated line to be worked on. There are a variety of ways to do this because of the variety of construction arrangements that can be found in a typical distribution system. For example, there are single circuits and double circuits. And circuits may or may not have protective static wires and may or may not have neutrals. You may encounter lines that cross over, are at right angles to, or are parallel to the line you're working on. And in addition, there may or may not be suitable locations to drive ground rods. These variations may require different approaches to establishing a safe that can be adapted to many different construction grounds on either side of the work area. We can look at an example to see how this can be done. We can look at an example to see how this can be done. Keep in mind that we're following the policies and procedures used by many utilities and procedures used by many utilities. The principles for establishing a safe work area are the same. In this example, a line crew has been assigned to do some maintenance work on an overhead three-phase line. Before starting their work, the crew will isolate and de-energize the line. Remember, in order to de-energize the line, they must apply grounds. Generally, grounds are installed at least one span away from the work site. If the grounding cables are close to the work site and the lines become energized, there could be violent movement of the cables that could result in injury. Before beginning work, the crew makes sure they have the proper grounding equipment. This equipment includes jumpers, which are made up of approved clamps and grounding cables. The size of the grounding cables used is determined by the maximum possible fault current that could be present on the utility system. The clamps are chosen for their current carrying capacity, as well as their mechanical strength. They must also be able to fit the conductor. During the tailgate meeting, the crew decides on the locations where the grounds will be applied after the line is isolated. Good judgment should be exercised in deciding where the grounding equipment will be installed. The crew wants to avoid any locations where accidental contact with energized equipment is possible. The line, which is on part of a Y-connected system, has been isolated. After making sure the equipment is in order and the worksite is prepared, the crew members begin to install temporary grounds at the designated locations. A ground rod is driven into the earth. The ground rod is then cleaned with a wire brush. A wire brush is used to clean the contact surfaces of the ground clamps as well. One end of a ground lead is connected to the ground rod. Traffic cones are placed next to the temporary ground rod as a visual warning of its location. Next, the lineman climbs the pole where the grounds are to be applied. And the line is tested for potential using appropriate potential test equipment. The surfaces of the neutral and phase conductors may be contaminated or corroded. So the lineman begins by using an approved wire brush to clean the neutral and phase conductors where the ground clamps will be applied. This is done to ensure positive low-resistance connections. The other end of the ground lead is sent up on the hand line and is connected to the system neutral. Next, a grounding jumper is sent up to the lineman on the pole. The clamps on both ends of this jumper are connected to the system neutral. Both clamps are connected to the neutral to prevent the jumper from dangling down the pole. The lineman uses a shotgun stick to engage one of the clamps on the neutral. The clamp is connected to the nearest phase. One phase is now de-energized. A second jumper is then sent up to the lineman. He uses the shotgun stick to connect one of its clamps on the phase he has just de-energized. And the clamp on the other end of the jumper is connected to the next nearest phase. Finally, a third jumper is sent up. Following the same procedure, this jumper is connected to the center phase and to the farthest phase from him. At this point, one set of grounds has been installed on one side of the work site. The same procedure is followed to install a second set of grounds on the other side of the work site. The grounds we just saw provide a path for current to return to its source and to Earth. This path is usually the path of least resistance, and the current flow is usually sufficient to activate protective equipment such as fuses or breakers. As we said earlier, there are other procedures that can be used to ensure your safety when you're working on overhead lines. When we come back, we'll look at another approach to grounding called equipotential grounding. But before we do, take the time to read the text material on how isolated or de-energized lines can become energized, and on the grounding example we looked at in this part of the program.